Welcome to Mr. Math Academy. Grow your math brain.
Hello friends, welcome back to Mr. Math Academy. So here in this video we discuss about what is the relationship between the Young's modulus and the bulk modulus here. So already we have discussed what is the generalized Hooke's law. So what is the volumetric strain for a rectangular bar cross section, and different things we have already we have studied the basic things here. Now let us move on to the what will be the relationship between the elastic constant like Young's modulus and the bulk modulus here. So we have to consider, to find out what is the relationship between the Young's modulus and the bulk modulus, we should consider that so there will be some cubic element which is subjected to a stress in all the directions x, y and z. So let us consider, I will just take the x, y and z directions here. So now this cubic element, so which is subjected to a stress sigma in all the direction, I am considering it what the stress in all the direction x, y and z, it will be remain same. So it will be remain same means I have considered it as a sigma, that is a stress in all the direction, it will be a same. Now what we have studied in the previous classes, we just remind here, we just recall. So from there we can easily get the what is the relation between these two elastic constants here. So what we have studied in the previous video is, so we have studied that, so epsilon v is equal to epsilon x plus epsilon y plus epsilon z. So means what, this is the so this is the volumetric strain for a rectangular bar cross section. So where epsilon x is nothing but it's a which for the, to remember in a easier manner we can write this epsilon x as so sigma by E, so sigma y by E, sigma z by E. Again, if you are finding the strain in x direction, means in x direction x, so for the sigma x I will just take the positive, but in the sigma y and sigma z I will take the negative with new value. I will just write with the new minus new here. So where new indicates it is a Poisson's ratio. Similarly I will just find out what is the epsilon y and epsilon z. So epsilon y becomes, it's a, first to remember in a easier manner, write sigma x by E, sigma y by E, sigma z by E. Now we are finding the strain in the y direction, means it's a epsilon y. So it means what, in that particular direction we have to take it as a positive. I'll just write in this position it's a positive, but in the other two terms we'll take it as a negative with nu, that is a minus nu Poisson's ratio. This is a minus nu here. Similarly I'll go for the third one, that is the epsilon z, that is the strain in z direction. So we write epsilon x, so this is sigma x by E, sigma y by E and sigma z by E. Now if you are finding the strain in the z direction, so we have to take it as a positive in that particular z direction. I'll write positive here, but in the other two terms we take the negative nu. So these equations are called as a generalized Hooke's law. So because these equations helps to find out the relationship between these parameters here, that is the Young's modulus and the bulk modulus K. Now what is the Young's modulus is nothing but what is elasticity, modulus of elasticity is nothing but it's a within that particular elastic limit if the normal stress is proportional to normal strain. So that is the Young's modulus. Now what is the bulk modulus? So bulk modulus is nothing but we can represent with this K. The bulk modulus can be represented with the letter K, which is given by, it's a volumetric stress to volumetric strain. So bulk modulus K is a volumetric stress to volumetric strain here. For the time being, to derive here, so this sigma V I will just take it as a only sigma here. Now where sigma indicate it's a volumetric stress and this is a volumetric strain. Now what happens, only with these two relation, now there is one more equation is there. Now if I take these three equations, that is a generalized Hooke's law, in this standard equation, that is in finding the what is the epsilon strain, it becomes epsilon V is equal to, after substituting these three equations in the equation here, that is a volumetric strain, I am getting the simple equation here, it's sigma x by sigma x plus sigma y plus sigma z by E into 1 minus 2 nu. This is what we are getting the equation after substituting this epsilon x, epsilon y and epsilon z in this volumetric strain equation. Okay. Now to derive the relation between, to get the relation between the modulus of elasticity and the bulk modulus, only thing is I will just use these equations here. So that with these two equations we can easily get the what is the relation between these two terms here. So what we have to consider here, I will consider this equation here. So consider means we know that, so volumetric strain, for a rectangular bar. So similarly, okay, we can take this epsilon v for this member also. We know that the volumetric strain is epsilon v is equal to, direct I will take this equation here. So it says sigma x plus sigma y plus sigma z by E, okay, into 1 minus 2 nu, right. Now what happens, the next thing is, so in that equation, so in this equation I will just substitute sigma x, sigma y and sigma z as sigma, because I have taken sigma is common in all the directions. So that is, it is called as that is a member is in a stress state condition. That is why in x direction, y direction as well as the z direction I am considering the stress will be remain same. Therefore, that is when I will consider a small thing here, that is a sigma, when sigma x is equal to sigma y is equal to sigma z is equal to sigma. Now you just substitute in this equation here, in place of sigma x, sigma y and sigma z, it becomes epsilon x is equal to, it becomes a 3 sigma here in the numerator, denominator is Young's modulus E, so into 1 minus 2 nu. Okay, I will take this is equation 1 here. Now again what I will consider here, so I have taken this equation now. Now I will take the bulk modulus, what will be the bulk modulus k is equal to sigma by epsilon v here. Consider the second equation, we know that k. Okay, before that I will just cross multiply, because this is a bulk modulus k here, I will just cross multiply this two term over here. So it becomes epsilon v is equal to sigma by k. Okay, from this equation I can write this as epsilon v is equal to sigma by k. Okay, where sigma is a volumetric stress and this is volumetric strain and k is a bulk modulus here. Okay, now these are the two conditions. Now I will take, this is a equation 2. Now epsilon v is equal to, that is the equation 1 and equation 2 is there. Now you just equate the equation 1 and 2. Equate the equations 1 and 2 so that we can get, so here it becomes so 3 sigma by E into 1 minus 2 nu, that is equal to sigma by k. Now from this equation the sigma get cancelled here, the remaining terms are, you just cross multiply this k to the left hand side and E to the right hand side, it becomes 3k into 1 minus 2 nu, that is equal to E. Therefore we can represent this, that is the relation between the Young's modulus and the bulk modulus is given by E is equal to 3k into 1 minus 2 nu. So okay, I hope you are getting this one. So where Ke indicates the Young's modulus, that is the modulus of elasticity, K indicates it is a bulk modulus here, that is the volumetric stress to the volumetric strain, this nu indicates it is a Poisson's ratio of this particular material here. So now this is the relation between the Young's modulus and the bulk modulus here. Okay, if you like this video, please comment, share it to your friends and subscribe to our channel. Thank you.